Okay, looking at lesson 3, we're going to look at the inequalities for these and then some matrices and how to solve a system using matrices. So just a couple reminders when graphing inequalities, your less than, greater than, less than, equal to, greater than, equal to. Graph them the same as you always would. So like this is your parent function, x squared. But make sure you ask yourself if it's a solid line or a dashed line. So like this would be a solid line. And because it's greater than x squared, we're going to shade above the line, so above your curve. This one is, again, a solid line. But because y is less than, we want to shade below the curve. Right? This one here would be a dashed line because it doesn't include the values that are on your line, but we're going to shade back above the curve. This one here will also be a dashed line, and we're going to shade below the curve. All right, so the solution to an inequality is every point that satisfies the inequality. Sorry, that should say inequality as well. When we consider systems of inequalities, the solution to each system is all the points that satisfy each equation. And so where that's going to occur is where your shaded regions will overlap when you have a system. Okay, so for example, here is a system with a circle and a line. So recognizing the type of function based off of previous units, this circle has a center of 0, 0, remember your h and your k, and a radius of 2 because this is r squared. Right? So we have our center at 0, 0. I'm going to go 2 up, 2 left, 2 down, and 2 to the right. This is a solid circle because it has that equal sign. And when your y is less than, or when your circle is less than your radius, you want to highlight inside of that circle. And so I'm just going to shade in here, light enough I can see what I'm graphing next. Sometimes with inequalities, I wait till the end and just shade what's called your feasible region, which is where your shaded regions will overlap. The second line here, I'm going to go ahead and solve for y. So y is greater than negative x, or negative y is greater than negative x. So y is less than x. So my slope is 1, and my y-intercept is 0. This will be a dashed line. And we're going to shade below the line. And so here we shade this area here. Now this double shaded region where this green is actually your solution set. So sometimes you might choose to just shade that region by itself. Go ahead and make that a little bit darker if possible, which is fine. So you don't really need that yellow there or the blue. That's your feasible region in there. So what we want to do next with that is find our vertices. And your vertices, and this is a bounded region, but we only have 2 vertices. Our vertices are still the points where these lines will intersect. And so for this particular one, knowing that y is essentially equal to x, if I replace that inequality sign along that line, y equals x, I can sub that in up here. And so x squared plus x squared is equal to 4. And I can just solve my system. Now, sometimes you can read them off the graph. In this case, I can't. So 2x squared equals 4, x squared equals 2, so x equals plus or minus 2. Y is whatever x is, so that leaves our coordinates to be, plus or minus the square root of 2. Positive square root 2, positive square root 2. or negative square root 2, negative square root 2. Right. This other one we will do together in class, or go ahead and try it on your own, or at least graph it on your own. We can talk about the matrices. With word problems, just make sure you read the whole thing. We're finding a system of inequalities, but treat it again like you would with your regular system of equations. So you have a coffee merchant selling 2 different types of blends. And in each blend, you have 2 different types of beans. The deluxe blend uses those same 2 types of beans as well. A merchant has 80 pounds of the first type and 90 pounds of the second type. And so those are your totals that you're going to look at here. So in the standard blend for your first type of beans here, you have 4 ounces in the standard blend and 10 ounces, excuse me, in your deluxe blend. So I'm going to use S and D here. And that's going to equal your 80 pounds total that you have. Well, they have that, so they need to be less than or equal to that when we add them together. We can't use more than we have. Our second total is 90, so we need to be less than or equal to 90. In our first blend, we use 12, or in our standard blend, we use 12 ounces of them, and in our deluxe blend, we use 6 ounces of them. We also need to just know that in word problems, typically we're going to be greater than or equal to 0 for both of those. So when you look at your graph, you're really only looking at quadrant 1. And so I'm going to let down here be my standard blend, or my S. And then the side be my deluxe blend, or my D. All right, you would graph these the same as you would a y equals mx plus b. So I'm going to solve this for D. And so I subtract the 4s over. Oops, sorry, less than or equal to, and divide by 10. And so my y-intercept is 8. And I'm going to go down 2 over 5, down 2 over 4. You could also graph by intercepts. So my y-intercept is 8. If I divide by 4, my x-intercept is 20. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry. I'm just kind of marking every 5 there. So I have that. So I can connect these. This is a solid line because it can be less than or equal to, and I will shade below, but I always wait to shade in these types of problems until I have all of my lines on there. Graphing by intercept here. If I divide 90 by 6, then I get 15. So my y-intercept is 15. And then if I take 90 divided by 12, I get 7.5. So somewhere in here. Or I can solve it and get it into the same format. So D is less than or equal to negative 12 over 6, so negative 2s plus 15. So that is fine too. Okay, so either way, this is a solid line, hopefully somewhat straight. And I would shade below that as well. So above my intercepts and below both lines is this little corner region here. And then your vertices for that region would be these 4 corners. Okay. That moves us into matrices, which is just another way to solve a system. And a great way for you to double check your algebra when you're going through. So you're going to rely on your graphing calculator for this. But just matrices in general are a rectangular array of numbers. A row in a matrix is a set of numbers that are aligned horizontally. A column in a matrix is a set of numbers aligned vertically. Each number inside of a matrix is called an element of the matrix. Matrices, plural, are enclosed in your brackets that you'll see around that, or parentheses. We don't use this very often, but if you're looking up extra resources, you'll see that they do. And they're usually named with capital letters, so matrix A, matrix B, matrix C, down here. We often refer to them by their dimensions, M by N, indicating M rows and N columns. Matrix elements are defined first by row and then by column. So for example, A is a 2 by 2 matrix, B is a 3 by 3 matrix, and C is a 3 by 2 matrix. Examples for elements, you might have A, and then it says, I don't know, 2, 1, which would be element in A, row 2, column 1, which is 3. Okay, something like that. Matrices can be added or subtracted together if we need to add or subtract that data, as long as the dimensions are the same. Okay, and so like this is a 2 by 3 and this is a 2 by 3. We can go ahead and add those together. And to add them, we're just going to combine our elements that are in corresponding positions. And so 1 plus -2 gives us -1. 5 plus -11 is -6. -9 and +9 is 0. All right, and we go through the second row as well. -7 plus 6 is -1. 0 plus 18 is -18. And 9 plus 4 is 13. And so that would be your answer matrix. This one is a 1 by 3, and this one is a 3 by 1. So these ones do not add. Okay. If you're doing scalar multiplication, we can also distribute that through. So this would be 6, -3, and 21 as your answer. With subtraction, just watch your signs. 1 minus -2 actually gives you 3. -5 minus 1 is -6. 4 minus 4 is 0. -3 minus -1 is -2. They may not put the matrices right next to each other, but the same rules still apply. Here we're adding matrix X to matrix Z. And so again, as long as this is a 3 by 2, and so is this one, we can do that and get our 3 by 2 answer as well. And so adding 9 and 4, 6 and 3, 5 and -1, 0 and -8, 5 and 7, 10 and 5.5 gets you your answer. These numbers on the outside are scalar multiplication, which is just distributing through. So everything in Z should multiply by 4 to get your answer. Okay. Make sure you follow order of operations with matrices as well. So we're going to add inside our parentheses first. So we're adding y and x together. And then we're going to distribute that 3 through to our answer. Now, notice with addition, the order doesn't matter because we're still just adding our like elements. With subtraction, the order would matter, just like with regular numbers. And as far as matrix operations go, multiplication, the order matters as well. And so we don't typically do that a lot by hand. This distributes through here. 2, 2, and that will be your final answer. Okay. If you have 2 equal matrices, that then means that their elements must be equal. So if 4, 0, 6, negative 2, 3, 1 is equal to x, 0, 6, y plus 4, z over 3, and 1, then those elements in corresponding positions must also be equal. So x is 4. Z over 3 is equal to 3, which means that z is equal to 9. And y plus 4 is equal to negative 2, which means that y is equal to negative 6. Right? So you can find those values using your corresponding elements. When we multiply matrices, the dimensions, the columns, excuse me, the rows, no, sorry, the columns from the first one must match the rows from the second. And so this is a 3 by 2, and this is a 2 by 1. And so because these numbers in here match, we can multiply these together. And the product will be a 3 by 1. To multiply these, though, because of all the steps involved, we're going to actually do this in a calculator. So I will walk you through that in class. All right, and this leads us to kind of where this ties into what we're doing now, using these to solve equations, to solve systems of equations. Okay, so the first thing we're going to do is put all of this into a matrix. And so we make sure everything's lined up in order that it should be. And then we take our coefficients and our answers and write them into a matrix. So if you have a system of 2 equations, then you should always have a 2 by 3 matrix. If you have a system of 3 equations, then you will have a 3 by 4 matrix. But notice we're not using any variables. You're just going to use the numbers. And then you're going to do it in your calculator. Now this does need to go in order, like this one would need to be flipped around here when I type that in, or when I write that into a matrix. Okay, so I'm going to pull up my graphing calculator. Okay, so to get these in your graphing calculator, you have a matrix button here. And so we're going to go hit second, matrix, and then we're going to go over to edit. And again, this is a 2, so I'm going to hit 2, enter, 3, enter, by 3. If it was a system of 3, it would be a 3 by 4, okay? So I need to get my numbers here. I'm just going to do this one on the left here. I have negative 6, 8, 17 in the top row. You do have to make sure you use this negative button or it will throw it off. So negative 6, I'm just going to hit enter and it's going to move automatically for me. 8, and then I already forgot my numbers, sorry. 17, and it goes down to the bottom row, and you can just hit enter every time. You can use the arrow buttons if you want. 13, negative 2, and negative 4. Oops. If you mess up, just go type over it, negative 4. I believe, let me double check my bottom row here. Negative 2, negative 4. Okay. And so this is input. Before I do anything with this, I actually need to go all the way back out to my home screen. So I hit second mode, which is quit. And then I'm going to go back into matrix. And now anything you want to do with your matrices is in math. And so like, if you did matrices in Algebra 2, you might have found a determinant. It has to do with the algebra and all of that. We're just going to use one of these systems here. You're going to go to letter B. You can go up or down. It's the one that says RREF. Okay, so you're going to hit enter. That's going to put that in your main screen. And this stands for reduced row echelon form, which is a formula that your calculator already has pre-programmed to solve the system. So I'm going to hit second and go to matrix again. Now some of your older calculators, the TI-83s, instead of hitting shift to matrix, they might just have a separate matrix button. Okay, so I go here and I want 1. You can edit over this one if you need to add more. You can add as many matrices as you want. And I enter. And then I'm going to hit enter one more time. You should see this happen where, and actually I'm going to hit math and convert these to fractions if possible. Yeah. Where this whole left side, and I just hit math enter, and it converted my decimals to fractions. But you should always have a diagonal of 1s and a diagonal of 0s, unless it is no solution or all real numbers. And so we'll talk about what that looks like in class. But this is now in alphabetical order based off of the way that I put them in. So 1 over 46 is my x value. And so 1 over 46 is the x value. And then the second value is your y value. So 197 over 92. So I'm glad I didn't have to solve that by hand. Okay, but you should always have that 1, 0, 0, 1, that diagonal of 1s, and then your x value and your y value will be in those last 2 positions there. Okay, they'll always go in order. All right, and so we're going to stop there for now, and we'll talk about what no solution and all real numbers look like in class.